The world of IP networking has a large number of terms. But did you know there are only 4 ways in which data is delivered in IP networks? In this video, we will cover these 4 ways and how they are used. By the end of this video, you will be able to understand unicast, broadcast, multicast, and anycast. So let's dive in. Unicast pertains to one-to-one delivery of data, one sender to one specific receiver. It uses the unique source and destination IP pair to transmit traffic. It's like talking directly to someone. Unicast is supported in IPv4 and IPv6. It's commonly used in emails, web browsing, gaming, and file transfers. However, if same data needs to be sent to multiple receivers, traffic is replicated one by one, which is inefficient. Due to this, other transmission methods are available. One is broadcast. It's the delivery of data for one-to-all devices in a subnet. It's like shouting to everyone in the room. There are 2 types of broadcast. First is limited broadcast. Traffic sent to 255.255.255.255. It is a broadcast generated only within specific subnet of the source. For example, in DHCP and ARP requests. Another one is directed broadcast. It is a traffic sent to the broadcast address of a given subnet. For example, 192.168.1.255 for a 192.168.1.0/24 subnet. It can be routed through the network to reach the particular subnet. One use case for this is for wake on LAN scenarios from different subnets. Broadcast is also used in legacy RIP version 1 routing protocol, but it can cause bandwidth waste and broadcast storms, since a large amount of traffic is sent at the same time to all devices in the network. Broadcast only exists in IPv4. IPv6 replaced it with multicast. Multicast is a delivery method for one-to-many receivers. These receivers are the only ones that are interested with the data. Multicast is supported in IPv4 and IPv6. Multicast address range for IPv4 is 224.0.0.0 to 239.255.255.255. And for IPv6, addresses inside FF00::/8. It can be configured manually, and under the hood, it is used by routing protocols to synchronize routing changes. Key aspects that you should note for multicast. It works when receivers join the multicast group with IGMP for IPv4 and MLD for IPv6. Traffic is routed using protocol-independent multicast. PIM builds the delivery tree across the network using the unicast routing table. It has 2 main modes. One is dense mode, wherein traffic is flooded first all over the topology, and after that, it prunes the branches that do not have listeners. It's only used in small or legacy environments since it's resource intensive. Another mode is sparse mode, which is commonly used in modern networks. It assumes receivers are sparsely distributed, so it builds the tree towards the central meeting point, which is called the rendezvous point. RP is just a router in the network that coordinates traffic between senders and receivers at the start of transaction. Once traffic is flowing well, direct shortest path tree is formed between senders and receivers without the RP. Multicast also has reverse path forwarding for loop prevention, which checks if the forwarding of traffic and reverse path is the same based on the source address. It uses the existing unicast routing table to check the traffic. The last traffic delivery method is anycast. It is a one-to-nearest communication. It leverages routing protocol's best path selection algorithm to determine which destination is nearest to the sender. How does it work? Suppose we have this topology. One network in US and another in Australia. We'll use BGP as routing protocol. In an anycast scenario, there will be 2 endpoints with same IP address. Let's use 1.2.3.4 as example. BGP will select the best path based on the lowest metric. In this case, the one with the lowest AS path. Therefore, the US network will see that the endpoint in US has a better metric. So when users in US connect, it will go to the US server. Same is true with users in Australia. They will connect to the endpoint in Australia due to BGP best path selection. In case there is a failure, users will automatically be routed to the other host with the same IP address. Anycast is usually used in content delivery networks and DNS to deliver the best latency to users. It can provide low distribution and high availability. Anycast can be used in both IPv4 and IPv6. That's every network transmission type. Like and subscribe for more networking videos. See you next time.